Hello viewers, if you watched my last video, you will recall that we covered the basic concepts of slicing and indexing. Today we are going to build on that foundation and dive even deeper into those concepts. Just to recap, slicing is a powerful feature that allows you to extract specific portion of a sequence without modifying the original data. Since here we are using one-dimensional tensor or a list, so the syntax we'll be using here is the start, the end, and the step. For detail on this syntax, you can watch my previous video. This start, it is the index where the slicing begins. It specifies the position of the first element you want in the sliced portion of the list. If omitted, it defaults to the beginning of the list, that is index 0. You can use the positive integer to count from the beginning of the list or a negative integer to count from the end of the list. This is the index where the slicing ends. It is pertinent to note that it is exclusive. It specifies the position immediately after the last element you want in the sliced portion of the list. If omitted, it defaults to the end of the list. Like the start parameter, you can use a positive integer to count from the beginning of the list or a negative integer to count from the end of the list. Third is the step. This is the step size which determines the spacing between elements in the sliced portion. It specifies how many elements to skip between each included element. If omitted, it defaults to 1, meaning every element in the range is included. You can also use a negative step to reverse the order of the sliced portion, but it works only in the list, not in the tensors. We will see how. For the sake of example, I have created a tensor consisting of 10 elements. Now I have already created the positive indexes of each element of this tensor. Also I have created the negative indexes which starts from the end of the list or tensor. The last element of the list or tensor has index -1. The second last element of the list or tensor has index -2, and so on. Here I have imported the torch and then created a tensor, and here I have created a Python list. I will take both of these side by side so that you can know that there is no much difference in the indexing and slicing of a tensor and a Python list. I will explicitly mention the difference where it occurs. Now if we want to select a single element of a list or a tensor, we don't need to follow this syntax. We will write the name of the list or a tensor, and within the square brackets we will directly write the index of the element which we want to extract. For example, if we want to extract the 0th element of this tensor or a list, we will write 0 here, and we get the first element, the 0th element, the element of the list at index 0. Now if we want to get the 5th element of this tensor or a list, 0, 1, 2, 3, 4. This is the 5th element of this list. So we will write 4 here and we will get 40. Similarly, if we want to get the last element of this list, we can write as -1 and we will get the last element. You can refer the indexing I have already provided here. Now using the negative indexes, if you want to extract the first element of this list, you can just write -10 and you will get the first element of this list. Now if we want to extract a slice of this list, we have to use this syntax. Note that it is not necessary to use all the elements of this syntax. For example, if I give 0:5, what it will do? It will start from the 0th index, means it will select this element, and it will go up till excluding 5th index, means 0, 1, 2, 3 and 4. We will get these 5 elements as a result to this statement. Now if I write 3:8, what will happen? Start index is inclusive and index is exclusive. Now it means that 0, 1, 2 and 3. The slice will start from 30 and it will go up to 4, 5, 6 and 7. So 30 including and 70 including. We will get these elements as a result of this statement. Now if we want to achieve the same results using the negative indexes, we can do so. For example, 70 is at index minus 3, which is exclusive. So what we have to do is we have to write minus 2 here, minus 7 here. What it will do? It will select the element at index minus 7, which is 30, and it will go up till minus 2 exclusive, means it will go up till minus 3. What is the element at minus 3 is 70. So we achieved the same results using the negative indexes. We can also combine the positive and negative indexes. For example, if I write 1 here and if I write minus 2 here, what it will do? It will start from the index 1, which is this element, and it will go up till excluding minus 2, which is 70. Now if I skip the end index entirely, what will happen? It means that the default is end of the list. So the selected slice will be from element 1 till end of the list. So element 1 is 10 and end of the list is 90. Again, if I write 5 here, 0, 1, 2, 3, 4, 5, this is inclusive. So the slice will start from 50 and go up till end. If I do not provide the start index and the end index, what will happen? The default of start index is 0. The default of end index is end of the list. It means the whole list will be selected. So if I write minus 1 here in the end index, what will happen? It will start from the index 0, means this element. It will keep selecting all the elements till excluding element at index minus 1, which is it will exclude 90 and include all the elements from the start of this list till 80. Now if we want to select the first 3 elements of this list, we just write colon 3 and we will be able to select the first 3 elements of this list. Similarly, if we want to skip the first 3 elements of the list, we will write 3 in the start index and we will skip the first 3 elements of the list. Now if we want to select the last 3 elements of the list, we will just write minus 3 here. It will start from 70 and it will go up till end of the list. Now if we want to skip the last 3 elements of the list, we will give minus 3 in the end index. It will start from the index 0 and it will go up till excluding index minus 3, which is 70. So we will be skipping last 3 elements of the list. Now we see the effect of step size in this statement. The default step size is 1. So in this case, we will be selecting the whole list starting from index 0, going till end of the list, selecting each single element. But if I increase the step size from 1 to 2, we will skip one element and the alternate elements will be selected. As you can see here, we are starting from index 0. So this element will be selected. We will skip the second element. This element will be selected. We will skip the third element and it will go on like that. If we increase the step size to 3, we will skip 2 consecutive elements. So here we will select 0, we will skip 10, 20, then we will select 30, then we will skip 40, 50, then we will select 60, then we will skip 70, 80, and then we will select 90, and that's it. Now if I just write minus 1 here, it will reverse the list. Negative sign says start from the end, go till the very start, selecting every element. So if I increase the step size to here, this negative sign says start from the end, go up till start and select only the alternate elements. Now if we mix all the three indexes, for example, we write 2 here, -1 here and 2 here. What will happen? It will start from the index 2, 0, 1, 2. 20 will be the first element which will be selected. The end will be -1 exclusive. This will be the endpoint, and we will be skipping every alternate element. So see, it started from the index 2, 0, 1, 2. This is the first element we selected. We went up till -1 exclusive. This is -1, we excluded it, and we went up till 80 and we selected every alternate element, which is 20, 40, 60 and 80. Now if we do -1 here, 2 here and -1 here, what will happen? We will start from the index -1, which is 90. We will go up till excluding index 2, which is 0, 1, 2. We will exclude it, means we will go up till 30, and we will select every single element. Also we will start from the reverse of the list. Now all these concepts work similar for the Python list and the PyTorch tensor. There is one deviation which I want to mention now. Remember, in Python list, if we used this, what it will do? It will reverse the list. But if we use the same syntax for the tensor, what it will do? It will return us an error. And what this error says? Step must be greater than 0. So Python list accepts the negative step size, whereas the tensor does not accept the negative step size. If you want to reverse the tensor, you have to write a code, which I can provide you right now. So here, to reverse the tensor, we can use built-in function. This is the syntax of that function. Torch.flip, it will reverse this tensor in the given dimension. Here we have just given the dimension 0 because we have a 1D tensor. Now if we execute these statements, we get this tensor reversed. That is it for today. Thank you for being with me in this video. My next video will cover a two-dimensional tensor and a 2D list. And we will see how the concepts of slicing can be applied in the 2D list and a 2D tensor. To stay tuned and this video reaches to other people, you can just give thumbs up if you like this video. Also you can subscribe the channel and hit the bell icon to get such more videos.